Hello friends, thank you for watching this video. I am Mohamad and today we'll be exploring multi-factor authentication, how does it work and how we can integrate it with .NET 5. So what are we going to be covering today? We're going to be discussing the problems, the security issue that we face in our modern day. What is multi-factor authentication? How does it work? What are its benefits? And how does everything fits together when it comes to multi-factor authentication on our normal application? And then we're going to be discussing the algorithms that's going to be used in order for us to generate the codes that's going to be used by multi-factor authentication. How does the QR code fit into this? And then we're going to be discussing the ingredients that we're going to be needing in order for us to implement multi-factor authentication. And then we're going to be implementing it. As always, you will find the source code in the description down below. Please like, share and subscribe if you like this video. It will really help the channel. So, first of all, the security issues that we're currently facing. When we create an account for any online service, we will have a username and a password to secure that account and make it private to us. But in this modern day, this type of protection is not enough, as we hear of on weekly basis of new hacks and new leaks of credentials of users. And if our account has been leaked or hacked, this could lead to serious problems and issues, as most of us are connect everything to our accounts, from payments information to address to mobile number. Major hacks and leaks includes companies like Adobe, eBay, Canva, Equifax, LinkedIn, and so many others like also FitnessPal, Yahoo, and so much more. So we need to secure our account further. So how can we secure our account further and make sure our accounts are secure even if our credentials are leaked online? This is where multi-factor authentication comes into play. So, what is multi-factor authentication? It's a process of identifying a user by a combination of methods, like credentials plus a one-time password we allow the user to log in, credentials plus some biometric information. We can also then allow the users to log in, or it could be a combination of three, like it could be credentials, biometric information, and plus a one-time password, and then we can grant access to the user to log into the system. For now, we're going to be focusing on the main scenario, which is a user with a one-time code. So that code will be unique. Every time the user tries to log in, they will need to have a new code, and then based on that, they will be able to log in. So how does it work before multi-factor authentication, any login system or any authentication system on our website? And we're going to see how does it work after multi-factor authentication. So in this graph here, you see we have like the login form, which basically consists of a username and a password, and then we have the login button. So once the user clicks on the login button, their credentials are getting verified. And once those credentials are verified, they are either granted access to the service where they are able to log in and use this service, or it's gonna get an invalid credentials and the user is redirected back to the login page. So this is only a one level of authentication, because basically the only level of authentication we are using here is the credentials of the user, which is a username and a password. So that's the case without multi-factor authentication. But with multi-factor authentication, things change a bit more. So let's take it into step by step. So the first step is here we have the users who's trying to accessing the system, and they're utilizing their credentials, which is basically the username and the password. So once the user input the username and the password and they click on the login button, they are sent to the verification process of those credentials. If those credentials face the first verification process, they are redirected back to the login page. In case they pass the first verification process, they are sent to a different screen where they have to input a code, and this code is one-time password. So every time the users try to log in, they need to input this unique code. And this unique code is generated by a third-party service on the, for example, user's mobile phone, where they'll be able, every time they want to log in, they will need to utilize their mobile phone to get that code, and then after that, they need to input that code, and then they will be able to, if the code matches the server's code, then they will be able to grant access to the service. And in case the code is invalid, the user will have multiple tries to try to re-input the code, but after a certain amount of try, they will be redirected back to the login page, and the user will be locked out for a certain amount of time. So multi-factor authentication, as we can see here, added an extra layer of protection in order for us to secure our account. So in case the credentials are leaked and everyone else has access to those credentials, with multi-factor authentication we can secure our accounts more, because that one-time code that's being generated is only available on our mobile devices, and based on that no one will be able to access our account unless they have access also to our mobile device and they will be able to get that code from the mobile device and add it here. So what are the benefits of multi-factor authentication? So first of all, it's ensure the customer's identity, because as we have said from the previous slide, in order for us to have multi-factor authentication we need to set up the second one-time code generator on our mobile phone, and in order for us to do that we need to have identified and created an account, and that's directly linked to our own identity. So that way we can assure that the customer identity is secure, and basically whenever anyone tries to log in, even if the username and password are being leaked and being used by someone else, the users will not be able to log into the system, because that one-time code is directly linked to the user's mobile phone. Second, it's because of regulatory compliance. So when it comes to, for example, banking systems or any high security systems or high secure information that we want to secure, the regulatory compliance means that we need to have multi-factor authentication in order for us to utilize those systems. Since the regulatory compliance focus on having high security, multi-factor authentication comes into play. The third benefit is SSO. So when utilizing single sign-on and we want to use a certain credentials to utilize across different services, it's always better to have multi-factor authentication enabled in order for us to protect all of these services that utilizing the same credentials. So in case those credentials got leaked, we don't really want the person who got access to those credentials to be able to access all of these services online. And this is where single sign-on and multi-factor authentication comes hand in hand in order for us to protect our account. And lastly, it's the security level, because it provides an extra level of security. It provides a peace of mind that our information, our account, and our personal data are all secured, because we have multiple levels of authentication and authorization in order for us to protect our accounts. So how does it all fit together? The first step is the user will register and fill up their information and their data and their email and confirm their email address. Once they did that, now they have to activate the two-factor authentication. When they want to activate two-factor authentication, they will need to log in again in order for them to verify their account. And once they click on activate two-factor authentication, they will see a QR code. And this QR code basically, it's like a URL which contains certain information and certain secrets inside that QR code. We're going to be discussing what's the information inside this QR code in more detail later on. But for now, let's just assume it's like a single URL with different information inside of that URL that's going to help us create this multi-factor authentication. So once that QR code has been shown to the user will scan that QR code with their mobile phone utilizing their authenticator apps, and they will be able to get a generated code on their mobile phone. So once that happened, the code will be able to generate every 30 seconds on their mobile phone. So right now, after the code has been generated and the multi-factor authentication has been created on that user's account, every time the user wants to log in, they will need to input the one-time code as well as their credential in order for them to get access to the service. So the code will be generated every 30 seconds, and every time the code is generated, it's going to be unique from the code that has been generated before that. So basically here, as a quick summary, we can see that in order for us to utilize multi-factor authentication, we need a different device than the actual computer or actual system that we're utilizing to create our account. Because, for example, if we're utilizing from our laptops, we need our mobile device in order for us to scan that QR code and actually generate the code that we need in order for us to log in with a multi-factor authentication. So, code generation. Multi-factor authentication use TOTP, which stands for time-based one-time password algorithm, which is supported by ASP.NET Core, with the combination of an authenticator app in order for have multi-factor authentication. But what is TOTP and what is HOTP? HOTP is an HMAC based one-time password algorithm, and TOTP is based on HOTP with a different combinations. We're gonna be delving more deep into what did this mean and how do they work together. In order for us to understand how the code is generated, we first need to understand how HOTP works and TOTP works. So now let's do an overview about HOTP. HOTP basically stands for the HMAC-based one-time password algorithm. And as we can see here from the graph, we have multiple inputs in order for us to generate the code. So we have a secret and we have a counter, and then these two are the parameters for the HMAC A-1 function. And once we have those parameters and the function runs, we get an output, which is the code. We're going to be delving more deep on how this works and basically where the secret come from, how does the counter work, what is dynamic truncation in more detail later on. But for now, let's understand that HOTP basically takes two parameters, which is the secret, which is fixed, which means it's shared by the server and the application, and the counter, which also going to be delving more deep into it. And then it utilizes some kind of algorithm which is called HMAC, which HMAC, sh-1, and basically this parameter take these two inputs and basically generate an output, and that output is usually very long in bits. So we utilize something called dynamic truncation, where we make it smaller in order for us to have the 6 to 8 digit code that we usually need in order to have our multi-factor authentication. So how does it actually this works? So the server and the phone will, as we said before, will both share the same secret, and the counter will be managed by each one of them. So in HOTP, the counter is being updated manually, so within the same function that we have mentioned before. So once we actually enable multi-factor authentication in our application, once we have enabled it and we scan the QR code, once we actually do the scanning process, the secret is being shared between the server and the mobile app, which is actually reading that QR code. And that way, the secret is known for the mobile app, which is generating the mobile code, as well the QR code, as well as the web servers actually sharing with them. So that's why the secret is actually shared between the two. The only variables between the server and the mobile phone, which actually is the counter. And with HOTP, the counter works differently than TOTP. First, we're going to be discussing the counter and how does it work with HOTP, and then we're going to be discussing the counter in TOTP. So when our phone on the server keeps track of the secrets, and the counter is value which is set to 0. So once we scan the QR code from the server from the server directly, we save our secret and we set our counter to 0. As well, the server will automatically set its counter to 0 at the same time that we do that. Whenever we want to get a new value, the counters goes up. So whenever we want to authenticate again, and let's say I open the Authenticator app and I want to get a code. So as soon as I open the Authenticator app and a code show up on my phone, the counter will automatically go up. For simplicity's sake, I just added +1, +2, +3, +4. This is in real life it's more complicated than that, but for now let's just take it in this simple scenario. So every time I open it and I take a code, the counter is automatically incremented by 1. And similarly on the server, every time I open it to log in, the counter is automatically incremented by 1. So if the code matches when we log in, between whatever I have on the phone and whatever the server has, is automatically approved, and I'm allowed to log into the system. So let's say I have opened my phone and I got the code, I have inputted into the server, and it granted me access. Great. But what happened if, for example, I opened my phone and I generated a code but I did not use it? So that means that the counter on my phone went up, but the counter on the server stayed the same. So what happened again if I went another time and I opened again my Authenticator app and then I copy the code, but I don't also utilize it? So that means the counter on my phone will go up while the counter on the server is still the same. So now we can see that we have discrepancies between the counter that's being utilized on my phone and the counter which is actually on the server. But luckily with HOTP we have a look ahead window. So basically the server will look into 5 slots ahead of its current position. So for example, if let's say I am on counter 2 and the mobile phone is on counter 5, because it's within the look ahead window, which is usually 5, the server will be able to authenticate me in, because the code that I'm giving to the server is actually within that look ahead window. So that way the server will know that the code that I'm generating, the code that I have generated is actually matching whatever possible counters in the future that the server might add within that look ahead window that we have. So it will authenticate me. And once the server authenticate me, it will automatically update its counter to that value that I have. So let's say I'm on counter 5 and the server is on counter 2, it will automatically update the counter on the server so it will match the mobile phone counter, so both of them will be on counter 5. And every time I want to log in, the counter will be updated either from the server as well as from the mobile phone. But what happens if I generate the code so many times on my phone which actually is outside the look ahead window that the server actually support? So in this case, there's not gonna be a lot of things that I can do in order for me to get granted to the system. The possible scenario is for me to turn off two-factor authentication and then reset the counter both on my mobile phone and the server by resetting and recreating the multi-factor authentication. And once I do that, I will be able to reset both of the counters and actually utilize them again, and the counter will automatically be reset to 0, for example, and we start the entire process again. So as we can see here, that this could be a problem that TOTP can fix. So everything else when it comes to HOTP is great, but the only thing is the synchronization of the counter as well between the server as well as the phone when it comes to the counter. And this is where TOTP will able to come in and will be able to help us solve these issues. So what is TOTP? TOTP is very similar to HOTP, except it's time-based. So the setup in the authentication app is the same. The only difference is the code is based on the current time instead of the sequence of values. So as we can see here that the two parameters that we're gonna be needing in order for us to generate the code is Unix time and the secret, while in HOTP it was basically a counter and a secret. You might think to yourself, why do you want to use Unix time instead of a counter? Let's think about it this way. Almost all modern computing devices, from mobile phones, tablets, computers, TVs, etc., have an internal clock, and that internal clock is universally the same with a slight margin of differences. So they are not exact equal to the milliseconds, but they are within a certain range of seconds of differences. So that makes them a very reliable counter and reliable variable that we can actually utilize. And the Unix system, which basically the Unix time system, which basically count the number of seconds since January 1st, 1970, it calculates the gaps between the current time and the initial time, which is January 1st, 1970, is a unique system and a system that we can actually rely on to be accurate to a certain extent. So this is why if we are using something in order for us to generate certain codes, we need a reliable variable which actually keeps on changing, but every single device might have access to. So for this reason, utilizing Unix time makes much more sense and is much more reliable than actually utilizing a counter. Because even if, for example, we generate 3, 4, 5, 6 codes and we do not utilize them, the server doesn't really care, because it's also basing its own generation and on the certain time. So let's say I generate a time now and I copy it and I put it inside the system. If it falls within the 30 seconds window that I'm allowed to utilize, the server will accept it and it will work, and it will not accept anything in the past, and it will only accept any code that might be generated in the future So this is why we can utilize actual Unix time better than utilizing the counter. So how does it work? As we have said, the Unix time is basically the number of seconds since January 1st, 1970, and the gap between the code is usually 30 seconds. We divide the Unix time by that gap, and we round it down, and we get the current sequence value, which we pass into the sequence value in the same code generation function as the HMAC as H1, which will provide the code of the current time. So as we remember previously, we saw that graph. Let's go back to it here, which actually take a secret and it takes a counter. So with TOTP, we don't actually utilize the counter, we utilize the code which is basically generated from the Unix time difference. So authentication apps will repeat the same process to generate the TOTP every 30 seconds as well as the server. And the validation for the TOTP code is a bit different from the HOTP code. So the authentication server will check the code within a certain window of the current time, and typically a few minutes. If that code is within that windows, it will allow it, and it will prevent the code to be reused, as we have mentioned earlier. So let's take this for example. So we can see here we have a time frame, which is basically a few minutes from that code generation. And we have a server who is, for example, 30 seconds behind. And my application is, or my phone, which is generating the code for me, is 30 seconds in the front. As long as they fall both of them under the same time frame, which is I think a few minutes from each other, because basically, as we said, there's always a bit of time differences between different devices, but usually all of them are within a few seconds difference from each other. So that's why we have this time frame, because we cannot make sure that every single mobile device, from tablets to phones to computers, are running on the exact same seconds and milliseconds. This is why we need to have this time frame. So within that time frame, if the code is generated, for example, from a mobile device, and it's actually mapping to, and it works with the Unix time that the server has, so it's within that time range between the two, it will allow me to log in. But in case it's not part of that time frame, or if it's outside that time frame, so what can I do for this? The first thing that I can do is I can give it another few minutes and wait for that server time to get updated until it reaches that same code that I currently have in order for me to utilize it. And if this still doesn't work, I need to disable two-factor authentication and go through the process again. But it's gonna be very, very, very rare that the timers between my phone as well as the timer between the server is gonna be different, because they are all based on the same Unix time, as we said, from 1970. And it will automatically sync up properly between them, specifically if they are connected to the same online service. So both of them will be able to utilize the same, or to a certain extent, an accurate Unix time. So now let's dive more deep into how does this code work and how is exactly the HMAC SH1 function works. So as we have mentioned earlier, we need two parameters for that function. The fixed secret is like a secret string, which is actually being shared between the server and the mobile device. And as we said, for the counter, it differs between HOTP and the TOTP. And because most of the systems right now and actually utilizing TOTP, we're going to be focusing on the TOTP. So once we have provided the secret, which is going to be shared between the server and the mobile phone, and the counter, which is going to be based on the Unix time, the HMAC function will utilize the underlying hash function SH1 in our case, and it will combine the secret and the counter to generate an output of 160-bit or 20 bytes long. And since the HOTP code is usually between, and since the TOTP code is usually between 6 and 8 characters long, the output of the HMAC function needs to be truncated into a smaller number of digits. And the numeric value is divided by 10 to the power of the digit and the remainder is the actual code. So let's us go a bit more into details of what's happened. So we have provided the secret, we have provided the counter, and then we gave those two into the HMAC function. The HMAC function, because it's relying on the SH1 in order for it to generate the code, the output of the SH1 is usually 160 bits or 20 bytes long, which is really long compared to the code that we want to generate, which is usually 6 to 8 characters, and we want to verify it against the server. So how does this work? In order for us to get from those 20 bytes into 6 to 8 characters, what we need to do is we need to truncate it and truncate that output into the actual code. And this truncation is called dynamic truncation. And dynamic truncation is basically the numeric value that we got, we divide them by the 10 to the power of digits. And the remainder will be actually the code that we can actually utilize. The truncation process is very complicated, and this is a very generic overview of how it works, but this is all what we care about right now. We don't really care about how that actually works from the inside. We just want to understand the general idea behind the dynamic truncation. So now, since we have covered this, the next step is we're going to be covering how does the QR code works and what does it actually contain. So once we want to scan our QR code from the server in order for us to enable it from our mobile device, we have something like this, which is this QR code. But what does it actually contain? So basically it actually contains a URL, and then within this URL it has the type. And the type here defines the algorithm type, if it's gonna be an HOTP or a TOTP algorithm. So once it has specified the time, then it's gonna give us the information name. From our mobile phone, we can see actually some app display information. So because within the authentication app, we might have different codes that we're generating for different application, and we wanna, for example, know what this code belongs to which application. For example, if we're trying to log into Outlook, we can see, for example, inside the Authenticator app, we have an information bar which is called outlook.com and account information, and these information are automatically populated from this app display info that is provided within the URL. And then within the query string for that, we have the secret, and this is the secret that's going to be shared between the server as well as the mobile device. So that's how we share the secret between the server and the mobile device. And the last point is the issuer, which is actually what is the authority which is issuing this secret. And in our case right now, if you're utilizing Outlook is the issuer. Once we have done this, now let us discuss what ingredients do we want in order for us to implement it within our .NET 5 application, ASP.NET 5 application. Basically, we're going to be needing two things, which is going to be VS Code as our code editor and .NET 5 SDK, which is going to be very easy to download and install. Now let's jump into it. So the first thing that we're going to be doing is we're going to be checking that .NET has been installed successfully on our machine. So how do we do that? We need to utilize the .NET -- version, and we should see the version number, which currently by the time of this recording is version 5.0.301. If you see any other number, that should be fine. If you see any error, you need to re-download and reinstall the .NET SDK again. Once we have done that, now we want to create our application. And for that, we're going to be utilizing the .NET new keyword. So we're going to put .NET new. We're going to build an MVC application. We're going to give it a name. We're going to call it multi-factor authentication code. And we're going to enable authorization out of the box. And we're going to make it individual. Great. Now let's click on enter. And this should take a few seconds for it to create. Perfect. Now it has been created. Now let's open up in our code editor. Great. Now it has been opened in our code editor. The first thing that we're going to be doing is just gonna go into the terminal. So we're going to go to terminal, new terminal, and basically we're just going to be building the application to make sure that it actually builds successfully. So .NET build, and this should take a few seconds. Perfect. Now the application is building. Let us run it. .NET run. And now we can see the application is actually running on port 5000 and 5001 for HTTPS. So let us open it in our web browser. And as we can see here, we have our application running on port 5001, and we have a very basic template of NSP.NET application. But the thing that we're really interested in right now is the register and the login. So if we click on the register, we have the entire registration process available for us out of the box utilizing Microsoft Identity. And let's create an account. So we'll create an account, Mohamad at email.com, and we'll give it a password. And let's register this account, and now it's gonna ask me to confirm my account. So let's click on confirmation. Confirmation email should be sent, and now let's try to log in. So I think it was Mohamad at email.com. And now perfect, I can log in utilizing my account. Great. So now let me stop this application. And the first thing we're gonna be doing, actually before we do that, let's run the application again. And let us go here and let's click on the name. Once we click on the name, we can actually see that out of the box, we have something called two-factor authentication enabled for us. Out of the box, we didn't do anything except creating our application, and it's already enabled for us. So once we have done that, if I click right now on add authenticator app, it's gonna take me to a page where I need to add this code, or I can actually enable the QR code generation, which is what we want and which we want to accomplish this time. But this is where we need to do some work before we can actually implement this, because if we look at the URL here, we can see that it's utilizing an area which is called identity, and then it has an account, then it has a manage, and it has something called enable authenticator, which is fine. But if we go to our source code, let's stop this. If we go to our source code and we open the areas, we see that we have identity, we have pages, but it's empty, and we cannot really see anything inside of it. Why is that? Because basically identity here is being utilized as a class library, and everything is compact. So the class library basically is the DLL file, and all of the files that we are seeing is being directly read from there, and it's utilizing Razor pages as this library, and we cannot really edit it, and we cannot really do anything with it at this moment in time. What we need to do is we need to actually scaffold it and actually generate it, and from there we can actually edit it and utilize it the way we want to. But the actual functionality is already there, but basically it's hidden inside this class library. So what we're gonna do is basically we're gonna be extracting those files from this class library and doing some minor edits to see if they're actually working, and then we can actually implement them. But in order for us to be able to extract them, there's certain steps that we need to do in order for us to get to that place. The first thing is we need to open our startup class, and we need to add inside the configure services method. First we need to enable Razor pages. So we go to services dot add Razor pages, because our identity is a class library which is based on Razor pages, and currently we have an MVC application, but if we want to utilize them we need to enable Razor pages. So this is the first thing that we need to do. And once that's done, now we need to go back to our terminal and we need to install two tools. So the first tool we're going to be installing is the code generator, and this code generator allows us to scaffold the identity. So .NET tool install -g, because we want to make it global, and we're going to be utilizing the .NET -ASP NET code generator. I have already installed this on my machine, but for you it might take up to a few seconds to be installed. As you can see, it has been already installed. The next thing we're going to be utilizing is the entity framework. So .NET tool install -global, which basically -g, and we're going to install .NET -EF, which basically allow us to have entity framework within our terminal. And as you can see, I have already installed it. For you, it might take a few seconds. Once we have done those, now we need to install extra packages into our application. Right now, if we open our CS approach, we can see that we have entity framework core has already been added, the identity, because basically when we created our application, what we did, we have added the -au individual, which basically makes it that we have automatically enabled authentication out of the box. And for authentication to work out of the box, we must have these packages. So by default, ASP.NET is smart enough, or the .NET framework is smart enough to know which packages it downloaded for us and did all of the wiring. So now we need to add more packages in order for us to able to scaffold. So the first packages that we're going to be adding is the code generator. So inside our terminal, we need to type .NET add package Microsoft .Visual Studio .web .code generation .design, and just it take a few seconds, and once it's done we can see it has automatically added successfully here. Perfect. The next one is gonna be entity framework design. So .NET add package Microsoft .entity framework core .design. A few seconds, and we can see it has been added successfully. Great. Now we need to add the Microsoft ASP.NET Core Identity Entity Framework Core, and if we look here, it has been already added for us. We don't really need to do that. Great. So the next one is gonna be Microsoft ASP.NET Core Identity UI, and we also have it automatically added for us. Perfect. The next one is going to be SQLite, and let's look here. We have already SQLite have been added. Now the next thing that we're going to be adding is the tools, which has already been added. So the last one is going to be adding SQL Server. So the reason we're adding SQL Server, entity SQL Server here, because within that package it contains certain libraries which allow scaffolding to happen for SQL. Because we're not actually utilizing SQL Server, but we need some libraries within that package. So how do we add that? Also very simple. .NET add package Microsoft .entity framework core .SQL Server. And this should take a few seconds as well. Perfect. Once we have done that, now let us just build to make sure that everything is still building. So .NET build. Great. Now everything is building and we have the green success message. Now let us utilize the code generation in order for us to be able to see the files. So first of all, we need to identify what is our application DB context, because this is going to be needed. So in order for us to know that, we need to go to the data folder, and inside the data folder we can see that we have our application DB context class, and if we click on it we can see the class name is application DB context. Great, that's all we need. So inside the terminal again, let's go to .NET ASP.NET the code generator. So we're actually utilizing the code, the tool that we have added before. And then we're telling it that we want to generate the identity from the class library. So we need to put identity. And once we've done that, we need to specify where is the data context. So we put -dc, which refer to data context. And then we need to actually specify the location of it, or basically the path through the namespace. So we can actually put fa code.data.application DB context, and that's it. And now as soon as I click on the enter button, let's monitor what's happening here inside this folder, and let's see what happens. So now I click on enter. It's gonna be building the project, running the generator, And as we can see here, we have a new folder which has been created, and we have a lot of files that has been created. So we have now something called the account. We have a lot of different stuff that has been automatically popped up. We have under the account, we have a lot of pages which have been generated for us. And under the manage, we have way more stuff. So before we didn't have anything except a single file. Now we have all of these files available for us, so we can actually utilize and use. So, and from here, as we can see, let's see what happened in the terminal. We can see it started building the project. It find the generator because we decided that we want to generate the identity, and once it found that identity generator, it start implementing it inside our project based on the DB context that we have provided, and then it has been generated for us. Great. So now that it has generated this identity for us, now let's run the application to see if anything different has happened. So again, .NET run. Perfect. We can see it's still running on the same port as before. Now let's go back to our web browser and let's refresh this. It's still showing as it should, which is what we want. And now let's do some editing, see if we can actually find this page. So it says that we need to go to identity, account, and then manage. So inside areas, we go to identity. Inside pages, we have account. Inside accounts, we need to go to manage, and then it's called enable authenticator. So let's find this page. And we can see here we have enable authenticator. So let's click on that. And we can see here that we have the actual text that is provided for us, which is here. Let's add just a sample. Let's see here. Let's put here, for example, Mohamad, just so we can test it out. And let's save this and let's stop and run it again. Okay, great. Now let's go back and let's refresh. And we can see Mohamad has showed up, which means that this is the actual page that we are able to run. So what do we want to do right now? We want to actually enable the QR code so we can actually scan it. And luckily Microsoft has gave us all of the direction that we need. And as we can see here, it even gave us a link on how we can add it. So let's go to that link. And as we can see here, it says in order for us to download the QR code for TOTP, we need to do all of this. So the first thing we're going to be doing is we need to download this library. So let's go and let's download the zip file. So now that my library has been downloaded, what I'm going to be doing is, as the instruction says here, we need to put it inside the www.root lib. So what we're gonna do is we need to put it inside the www.root lib folder, and let me copy it directly from my download folder here. So I can do this. And let's just call this QR code JS. Okay, great. Once we have done this, let's see what's the next step. To follow the instruction, we already have enabled scaffolding and we have already able to see it. And then it says we need to locate the scripts at the end of the file, which is this, and we need to update it to this. So let's copy this. And let's go here, and it says on the end of the page we need to update it to this. And basically we need to update this so it's not directly in the library. We need to add the folder, which is gonna be QR code JS, and let's save this and let's see if there's any other instruction. And then it says delete the paragraph. Okay, let's delete that paragraph, which is here. Let's delete this div, we don't really need it now. So now let's save this and let's stop the application and let's run it again. And let's go back to our web browser and let's refresh. Perfect. And as we have seen now, after we have added that library, we can see that the QR code has automatically been generated for us, and that's what we actually want. And we're going to be doing right now is we're going to be scanning that QR code from our mobile device and enabling it. So right now, if we look at when we hover above the QR code, we see that we have the URL has been generated, and we can see the first thing is TOTP, which is the algorithm that we want. And then it gives it the name that's going to be displayed on our application. Then we can see the actual shared secret, and then we can see that the issuer, which is going to be our application name, and then we can see that number of digits that is required, which is going to be 6. Cool. So right now what we're going to be doing is I'm going to be opening the Google Authenticator app on my phone. We can use the Microsoft one, but for now I have the Google one available. I'm going to be recording this from my phone, and we're going to adding the process directly on the screen next to it here on the next to the video. So once we open the Google Authenticator app, we can click here on the plus button, we can click on scan QR, and we can see here that it has automatically taking the code here, so we can see directly from that mobile screen that we have MFA code, which is the name of our application, and between parentheses we can see that the name that we want to utilize, and which is my account that I have created, and we can see that the code is being generated. So right now what I can do is I can just input the code that's showing here, which is going to be 777898, and if I click on verify, we can see that the Authenticator app has been validated, and basically it's working now. So we need to put these codes in a safe place. Let's copy them and let's add them somewhere in our source code, because we don't really care about it. So for now, let's just put them anywhere here, and let's try to log out and log in. So we put on log out and log in. It's gonna request the information, so my email address and the password. And once we click on login, it's gonna take us to the Authenticator app for us to add the code that we have added. And now let's add this code, which is gonna be 834281. And if I click on login, we can see it logged me in. But if I go back to log out and log in again, and let's say I want to input my correct credentials, mohamad@email.com, and I put the right password, login, it's going to ask me for my authenticator code. But if I put the wrong authenticator code, let's put 111111, for example, click on login, invalid. No matter how much I try, it's going to be invalid. Now let's give it a few shots, and we can see that the more that I put it, my account has been locked out, which is what I wanted, even though that my code is being generated, because it's not matching the one that has been automatically popped up. It has locked me out. Great. So this is basically gonna we have covered right now the entire multi-factor authentication, the process behind it, how does it work, how is it shared, what's the logic behind it, what's the algorithm, what is TOTP, what is HOTP, how is the code being generated, how the application knows about it, and so on and so forth. Please write down any question that you might have in the description down below, and thank you very much for watching. Please like, share, and subscribe if you find this video helpful. Have a great day.